What's up guys, Lazar here from How to Rhino, and in today's tutorial we are going to cover Evolo competition winners from 2018 and how to model it using Grasshopper. The project is a tensile structure and we'll learn how to combine Grasshopper with physics solver Kangaroo. Without further ado, let's get started. You all probably heard about the Evolo Skyscraper Competition, which is an annual call to architects, designers and urban planners around the globe to explore new ideas for vertical living. Established in 2006, the Evolo is one of the world's most prestigious awards for high-rise architecture. For this tutorial, we picked the winner from 2018. The project is called Foldable Skyscraper for Disaster Zones, designed by Damian Granosik, Jakub Kulisa and Piotr Pańczyk. Now let's go to Grasshopper and see how to make it. Alright, in the first step we'll set the point that it's going to be the center of the rectangle, positioned on the XY plane. Using construct domain, we'll set X and Y dimensions, and in the slider we defined how big the rectangle will be. With a linear array, we're going to multiply a rectangle 20 times along z direction, with a distance among them will be 4. With the shift pattern, we'll take out every second rectangle. They will keep their index item, and we're going to rotate by 45 degrees. So just one set of rectangles will be rotated, another one stay in the same position, and with the combined data we will merge them again in the original list. In the next step we are going to scale them using combination of the range, graph mapper and remap components. Basically, so once we equally distribute numbers from 0 to 1, we will place them in the graph mapper, Bezier curve, remap them into domain from 0.75 to 1.2, which means 0.75 will be the smallest scale factor and 1.2 will be the largest scale factor of the rectangles. Once we have rotated and scaled rectangles, we can use component circle fit to create a circle around each rectangle. Based on these circles, we'll create a surface, but don't forget to set true value in align input of the loft option. In the next step, we'll create a mesh based on the surface. In the U and V input, we set the number of divisions. Its vertices will be welded with the component combine and clean from the Kangaroo tab. Now we need to define anchor points. One set of anchor points will be corners of the rectangles. So basically we will take out its corner and pull to the mesh points. Another set of anchor points will be naked points of the mesh, pull to the closest rectangle. Once we define these two lists of anchor points, will be merged into one. And we will call it anchor points. This is the one thing we need for the Kangaroo calculation. In the next step, we need to define Kangaroo springs. Basically, we'll take all mesh edges, calculate their length, and multiply by a certain factor. Based on that parameter, the tensile structure will be generated. So usually that number it's from 0 to 2. If we have number less than 1, the tensile structure will be created. So the smaller number is, the more straightened the structure will be. Once we have springs and anchor points, we'll create a show mesh. And once we have these three guys, we can place them in the Kangaroo bouncy solver. Don't forget to create toggle and button component. Now we are going to take out only the first item from the output, as we only need the mesh. Okay, and once we set toggle true, we can start the calculation, and you can play with this slider. If we set 0.4, the tensile, the structure will be more straightened. If we set back, we can also play with the strength input. So if the strength is bigger, also it will affect the creation of the shape. I will set back, I like how it looks with 0.7. Okay, once we get the shape we like, we turn off the calculation, take the mesh and place in the Clark subdivision component from the VRBur plugin in order to get smoother mesh. Now we need to go back in order to create diagonal lines with the component relative items. So first we'll take rectangle corners, separate their branches into two lists, one with even and other with odd branch numbers. You can also use a split tree component for this purpose. And once we divide these two branches into two lists, I'm going to visualize point numbers so I can better explain the next step. Before we continue, I just want to mention the extended version of this tutorial, which will be focused on rendering and animation with V-Ray. First, you will learn how to create and apply V-Ray materials, then how to add V-Ray Infinite Plane, the lighting, and how to import name views from Rhino into Grasshopper, then how to use them for renderings with V-Ray camera components. On top of that, we are going to show you how to combine Kangaroo with V-Ray and how we can render each iteration and create animation from them. You can watch this version on our Patreon page and support our work at the same time. With that, you will also get access to all our extended tutorials and project files. So basically, same index points from even branches will be connected with the points from odd branches. Also, they will be connected with the points that have index number -1. That's the method how we can create a first set of lines from one point. +1 means the branch larger than the current one. 0 means the same index item. So +1 branch, 0 item, and +1 branch, -1 item will be placed in the offset relative input. That's the one set of line. Another set of lines will be created connecting the same index points from odd branches with the points from even branches. In this case, they will also be connected with the points index number +1, points from even branches. So it means the relative offset here will be +1 branch, 0 item, +1 branch, +1 item. Don't forget in both of these cases to set wrap item to true. Once we have all diagonal lines, we will merge them into one list. These lines will be divided into 5 segments in order to create the points that will be pulled on the mesh generated from the Kangaroo solver. Based on these points, we create a curve, and after that the pipes with the radius 0.1. So here with interpolate we create curve and pipe, and the radius we set 0.1, and don't forget to set 2 in the E input, which means rounded caps. In order to avoid pipes going through the surface, I just want to scale them a little bit. In this case, we'll use scale NU, and in the input X and Y, we'll set 0.87. Okay, and in the last step, we need to create the floors, basically intersecting rectangle planes. With the mesh, we can create curves. Once we get the output, we'll convert them into surfaces. With the prune tree, we take out only branches that have a single item in the list. It means that curve should be closed one. And once we get the curves, we can create the surface. Then we'll take the output scale for the same reason we did for the pipes. So for the scaling factor, I will set 0.98, and then with the extrude component, we'll extrude them along a z-axis. But before that, there is one step in between. We can simplify curves in order to have less control points, which means the geometry will not be that heavy. After simplifying curves, we can create the floors. And this is how we get all three elements: the mesh surface, diagonal structure pipes, and the floors. Before I wrap this video up, I would like to share something with you. If you are in architecture and you're interested in learning more about Rhino and Grasshopper, but you're tired of searching through thousands of tutorials online and wasting so much time doing that, and you're looking for a structured learning approach with one-on-one support, we created a course called Rhino for Architects that will guide you through all of the basics, both Rhino and Grasshopper. In addition to that, we'll be covering some advanced modeling techniques using subdivision tools for Rhino 7, which will allow you to create any kind of geometrical shape that you imagine. When it comes to Grasshopper, we'll explain every single essential component with examples and homework files, so even if you're a total beginner, you'll be able to understand the logic and mathematics behind the program. On top of that, we'll teach you all about various plugins for Rhino that are used in architecture, such as V-Ray, Visual Arc, and even Bongo for architectural animation. Lastly, we'll cover architectural presentation, creation of diagrams, and a couple of case study projects. If this sounds like something you would like to check out, feel free to schedule your free Zoom call with us in the first link in the description. On this call, we will evaluate your current skill sets, determine if this course can help you out, and on top of that, we will share our learning platform with you so you can get a better idea how all of that looks on the inside. Click on the link below the video and we'll talk soon. Take care.